Hey everyone, welcome back to the channel. So today we will be talking about cache. So caches are uh, one of the most important topics in a system design interview, and that will help you to strengthen, like this video will help you to strengthen your concepts about cache. So we will be talking about various things today. So let me just give you an overview of things we will be talking about. So firstly, we will be talking about what is cache and basically a introduction to it. Then we will be talking about yes, how does caches exactly work? How does cache works, right? We will also be talking about the types of cache. We will be talking about the cache invalidation methods or the types of cache invalidation. We will then talk about the eviction policies that we have. Uh, right, so we will be talking about eviction policy. So this is the agenda for today's video, and let's get started. So basically, in the previous video, if you haven't seen my previous video about load balancing, please go and have a look. Right, I will drop the link to it in the description. So we talked about load balancing, and that helps you to scale horizontally. Right, load balancer helps you scale horizontally, but how caching will help is it will enable you to make vastly better use of the resources you already have. So I mean, load balancing, what did it do? So if you have multiple servers, then load balancer, you can place load balancer in front of it, and it will help you to redirect or distribute requests to minimize the load, or right, something of that sort. But within this server, how can you optimize computation, right? Here is when the caching comes into picture, right? So whatever existing resources you have, how can you make best out of it? That's the main aim we are trying to achieve, right? So basically caches use the principle of locality of reference. What does it mean? So locality of reference means like whatever the data has been recently requested, it will likely to be requested again. So let's say basically let's say you might have seen like someone posting a tweet which got famous, right? So how what Twitter will do is store this tweet in a cache, so that since this is a famous tweet, it will likely to be requested again and again by various users, right? So that will help to reduce the time Twitter takes to get this tweet. So it can store it into the cache, right? So whatever is recently requested can we can get out of the cache without querying from the database or something of that sort, right? Cache can be used at any layer, like it can be used in hardware, in your operating system, in web applications, or even browser. It's like a short-term memory, right? uh, but yeah, generally it's faster than what the memory we have, like hard disk and stuff, right? It is faster than that. So that's the basic introduction. Now we can talk about like how does cache actually work, right? So typically what happens is in a web application, data is stored in a database, as you might know, right? Data is stored inside databases. So when a client requests some data, you go and get it from the database and return, right, to the user, or the front end, something of that sort. But but always remember that DB calls, right? DB calls involve majorly two things. It is a network call, since you go and access DB, like DB is generally a different server and you go and access it over a network, right? So it is a network call and it involves IO operation. So it's like a costly operation. Querying a DB is not a fairly simple or operation, it's a complex operation, and it is a time consuming. It is a time consuming process, if you think, right? Yeah, it is a time taking process. Now, uh, so what cache does is cache helps in reducing this network call. Cache helps in reducing this and speeds the performance of the system, basically, right? The same example I gave, right? Let's say a tweet become famous. then Twitter will store it in the cache. So the network call will be saved in that case to go and fetch the tweet from the database, right? So basically you can have different types of cache. You can have in-memory stores, like Redis, or you can basically have like global cache. So there are different types of cache possible. So let us talk about the types of cache, right? So first we will talk about application server cache. Okay. So what is the application server cache? So basically, uh, so let's say web server as a single node, right? A cache can be added in this in memory, right? Alongside the application server. So user request will be stored in the cache, and whenever the same request comes again, it will be returned from the cache. So for a new request, data will be fetched from the disk and then it will be returned. Once the new request will be returned from the disk, it will be stored in the same cache for the next time request from the user. So let us take a look how generally application cache server works, right? So let's say you have application server. Let's say this is your app server, and you have, let's say, Redis cache or some sort of cache here. So let me call this cache, right? And let's say you have a DB over here. Let this be a DB, right? Now, so you fetch data from the cache. You go and fetch data from the cache. So here you, whenever request comes in, you first check the cache if the data exists, and if it exists, you directly return the data, right? And then if the data doesn't exist, right, in case of a cache miss, you go and query the DB. So you go and fetch from DB, and then what you do is you purchase the data back to the cache. So you purchase this data into the cache again, cache purchased, whatever came from the DB. So this is the first step. This is the second step. If it is in the cache, you return. If it is not, you go and fetch from DB and purchase inside the cache. So this is how application server cache generally works, right? So when you place your cache in memory, then some of the storage will be used by the cache, right? So if you're generally trying to cache small amount of entries, generally in memory cache are a good option. But let's say you want to scale your system now. You added multiple servers in your web application. Let's say there are multiple app servers instead of single one, right? Because like one node cannot handle a large volume of requests. So you can go ahead and add multiple servers. Then if you add multiple servers, let's say this is the server number 2, and this was the one, and you have a load balancer fronting them, then actually you will need one cache for every app server, right? And then there will be a lot of cache misses because each node, so this node is unaware of already cache requests, because let's say the first request for one user came to the server 2 and the next request for the same user went to the server 1, and they both have their independent cache. So let's say this is the cache 1 for app server 1 and this is the cache 2 for app server 2. Then then although the data for the user 1 will already be, let's say, yeah, first time the data came for the request came for user 1 and it is served by app server 1. App server 1 goes to its cache, writes goes to its cache. It says the data is not there. It goes to the DB and caches it into the cache 1. The next time the same request went to the server 2, then there will be cache miss because the cache 2 won't have that data already, right? So this is the issue. That's where the need for distributed cache or the global cache comes into picture. So let us talk about distributed cache now. So let us talk about distributed cache. So as we mentioned, application server cache are not generally good if you want to scale your application. That's when you need distributed cache. So each node will have a part of the whole cache space, and then using the consistent hashing or some sort of caching, we can route request to where the cache request could be found. So if you need more detail about how consistent caching is done, let me know. I will make a separate videos. So yeah. So how we can think of it like is, let's say we have 5 nodes in our distributed system, and we are going to use a load balancer to route the request. So let's say we have a load balancer. Let's say we have a load balancer. Yeah. Let's say we have a load balancer over here, and uh, we have like various application servers, right? So these are app servers. So each server will have its own cache. So these are caches. So each server is having its own cache, and there is one DB. So each of the nodes will have their small part of the cache data. So there will be some data here, there will be some data here, and there will be some data like here. And then how? So to identify which node has which request, the cache is divided using a consistent hashing. So consistent hashing is a concept which is generally used when you are distributing requests, right? Using that, it can be found that the each request can be routed to which like cache. So if a request node is looking for a certain piece of data, it can know where to look within the distributed cache, right? So we can easily like increase the cache memory by simply adding the new node to the request pool. So this basically what I was saying is, using consistent hashing, we can know where in which cache the data might be there. So the server one can talk to multiple caches here. It need not be the case that like this app server need to talk with only the app server one need to only talk with the cache associated with it. So it can need not talk only with this, but it can just communicate with any other cache over there. So this is you done using consistent hashing. So yeah, let me know if you need more information on consistent hashing. I will be happy to make a separate video on that. Okay. So yeah, this is beneficial when you want to scale your system. So that's where the distributed cache come into picture, right? And there is another concept called global cache, which also helps you in scaling. So let me talk about global cache now. So so as the name suggests, like the global cache, we will have a single cache. So if you have seen previously, we had app servers like this, and then we had separate caches for every app server. But instead of that, we can have a big global cache itself. And here the data can decide, and everyone will talk with the central or the global cache. So this app servers will talk only with the global cache up here. So every request will go to this single cache space. There are two kinds of generally global cache. So first, when a cache request is not found in the global cache, so here we will have the DB. So the global cache will be talking with the DB, right? And even in the previous case, there would be a DB, right? So when cache request is not found in the when a cache request is not found here in the global cache, right, then it's the responsibility of the cache to go and get that data from the DB or like anywhere, right? And then have it into the cache. Another logic is, the request comes and the cache doesn't have the requested data, the node or the app server will directly communicate with the DB. So in one case, it's the responsibility of the cache to keep it updated and get the data from DB. In another case, it's the responsibility of the node. So it's like, yeah, this is how global cache works. Another thing is CDN. So this is an important concept. I will be discussing this. CDN is a very important concept. I will be discussing this in a shorter way, but yeah, if you need a detailed explanation, let me know. I can make a separate video. So CDN stands for delivery, or you can call it content distribution network. So yeah, you can call it content distribution network. Sorry for the handwriting. Yeah, so it is content distribution network. Content, some issue with my drawing tab, but that's fine. Content distribution network. Okay, so yeah, yeah. So in a CDN, so CDNs are generally used when there is a large amount of static content to be served by the website. So there can be HTML files, there can be CSS files, there can be JavaScript files, pictures, videos, etc. So these are static content, right? And this can be cached to a location which is near to the user. So let's say you are sitting in NY and your actual application or the server sits in Mumbai, right, in India. Now you can easily cache the static content at a server near to NY, so that you can easily just serve the static content right away. So the static content don't need any dynamic computation of sorts, right? So you can store this static, frequently access static content at a location near to the user. So here, during the first request, you will go and ask for the server which is in Mumbai, but at the next turn, you can just return from your CDN cache. So this is the concept of CDN, like the CDN cache near to New York. So first request will go to Mumbai, and then so this is just an example. There can be multiple locations in the map where CDN exists. Cloud providers have their separate CDN services that they provide as part of their package. So this is basically how CDN works, and it is kind of cached as well. Okay, there can be a lot of details I can give out CDN, but just comment if you need a detailed video. Now let us talk about the uh, cache invalidation, right? What sort of cache invalidation we can do. So caching is awesome, right? We have learned that caching is a great concept, but what if the data is consistently being updated in the database, right? What strategy do we adopt to keep our cache in sync with the DB, right? So you have to keep your cache in sync with the DB so that you don't return any stale data, right? So for that we need some cache invalidation approaches. So there are various approaches. So there are three approaches. The first one is write through cache. Write through cache. So how write through cache works is, so as the name suggests, the data is first written in the cache and then it is returned into the database. It's a write through. So if I have to draw a diagram for the same, then it will be like you have your request coming into your server, and then you have, let's say, a meme cache or a Redis server. Let me call it Redis, and then you have your DB, right? So now what will happen is, first your data will be returned to the cache. So if the request comes in, let's say there is a post request and data needs to be put into the DB. The data will be returned to the cache first, and then it will be returned to the DB. It's like a simultaneous operation, right? So cache and database always will be in sync because you do this consecutively. Like you write to the cache, you write to the DB. That's it, right? So this way you have the consistency between a database and cache, and every read done on the cache allows the most recent write. What is the advantage of this approach, right? There is minimum risk of data loss because you're already keeping everything in sync. So no data loss. There is no or minimal data loss, right? But what can be downside is that there would be higher latency for write operation. So you are basically doing 2x write operation for every request. You are writing to the Redis, you are writing to the cache basically, and you are writing to the DB. So your write latency is pretty high, right? And if you don't have a large amount of data, then it's fine. But if there is a heavy write operation, then probably this sort of cache invalidation is not good for you, right? So basically in application, there are a lot of read requests in the data. Once it's persisted, their write latency can be compensated by a lower read latency. So if you have a lot of reads are very high and there are not so frequent writes, then this suits your use case. Another sort of cache invalidation strategy is write around cache. So what happens in write around cache is that so similar to write through, right? You write to the database, but in this case you don't update the cache. So let me tell you what I am saying, right? Let me draw. So you write you write to the database, but you don't update the cache. So data is written directly to the storage and not into the cache. It bypasses the cache. So you don't really need to have the cache loaded with the data that would be reread. So in this approach, the write operation latency is, so in this approach, if you see, the write operation are not like much costly because you are writing only to the DB every time. You are not writing to the cache, right? But a read request for a recently written data will miss the cache. So it's like you will have a lot of cache miss if if you are reading a recently written data, right? So this is generally suitable when you don't frequently read the most recent write. So diagram, how will the diagram look like? Let's say you have the app server here, you have your cache over here. So this is the cache, this is the app server, this is the cache, this is the app server, and this is the DB. Then what happens in this case is you write data to the database, and whenever there is a request, we always go to the cache. But if there is a cache miss, we go to the DB, and then we write the data to the cache, right? So basically it's not the written. So this is the first step. You write data to the database, and whenever there is a request, so cache queries database for missing entries. So let's say the request came in, so the cache will query the database for the missing entries, then update itself. So yeah, write operation, we are not doing 2x write operation here. It's only writing to the DB, and there will be a lot of cache miss because if there is a request for reading the data that has been recently written, because again you will be going to the cache will be going to the DB and then updating itself. So that's another type of cache. The third type is write back cache. So we have talked about write through cache, we have talked about write around cache, right? Now another type is write back cache. So write back cache. So the names are pretty explanatory for the work they do. So when we talked about write through, right, you can think it of cache is coming in between the DB. So let's say this is the DB and this is the cache. So write through is going through the cache. Write around What can you think of is right around? So right around is you came and you went around the cache. So this is right around cache. You then write to the DB basically, and the request to the cache will go to the DB and update itself. So this way. So it's pretty self-explanatory, the names. Now let us understand what exactly is write back cache. So we have discussed that a write through cache is generally not suitable when there are a lot of write heavy system, right? Due to the higher latency of write request, and your latency will, the system will blow up, something of that sort. So we can in this kind of system we can generally use the write back cache. So firstly we remove or flush the data from the cache and then write the data to the cache alone. We write the data to the cache alone. Once the data is updated in the cache, we just say that the data has been modified, which means the data needs to be updated in DB later. So what we can do later is we can have a async job that will be performed, and then we can update our modified data into the database, right? So how this looks like is basically you every time, let's say this is your server, this is your cache, and this is your DB. So anytime you have a write request, you write to the cache and acknowledge that you have written, right? Acknowledge. You don't really need to go back and update the DB at the same time. So this is like an improvement of write through when you have a lot, because you are saving the 2x write, the 2x write here. At the same time you're only writing to the cache, but the request for the most recently returned data will actually be get served from the cache, so that also will become fast, right? But how do you keep your DB updated? You have to keep a DB in sync, right? So you can have a async job. So let's say this is an async job, so you can run this async job quite frequently, and this async job will take the recently updated data or the delta of the changes from the cache, and then it will go on and update your DB, right? So this is how a write back cache works. But the problem you can easily identify is that until you schedule your database to be updated, so until your async job is scheduled, the system is at the risk of data loss. So let's say you updated the data in the cache, but there's a disk failure, right? And you cannot really now modify data that has been updated in the DB. I mean your data then won't be updated in the DB if there is a, let's say, cache failure or something of that sort, right? So that way you won't be able to, yeah, that way you will be at a risk of data loss basically. So there are trade-offs for each approach, uh, and then if you read the data from the database and if it's not updated, then you will get inaccurate data and it will be not be consistent. You will be getting false results. So ultimately your database should be the source of truth. So if you are only updating the cache and then having a sync job, write to the DB, and meanwhile some other application or some other component of your service reads from the DB, it will get stale data, right? But so this is a trade-off depending on whether your application is write heavy, read heavy. You have to think about your architecture: write back, write through, or write around. Not really write around. Yeah, write back, write through, and write around. So these are the various approaches. Now let us talk about various eviction policies that we can have. Okay, so we were talking about eviction policies, right? So when we talk about eviction policies, there are mainly like four types of eviction policies. The first one is LRU, which is least recently used. Second one is LFU, which is least frequently used. The third one is MRU, which is most recently used. And the fourth one is random replacement. So these are the four eviction policies that we can discuss. So again, let us start with LRU first. So this policy basically, to give you and fair bit of idea, it is the most popular. Basically, it is the most popular due to like several reasons. So as the name suggests, the policy evicts the least recently used item first from the cache. So when the cache becomes full, it just removes whatever the item was least recently used, and the latest entry is then added to the cache. So let us say you are adding an entry to the cache. So you keep it at the top, right? And whenever there is a call to this, let's say this is a user post and someone is requesting to see this post. So uh, so yeah, like someone has, let's say, made a post, right? And everyone wants to see this post. So this post will be always be kept on the top of the cache. So this post always remains at top of the cache because it is getting accessed again and again, and thus this won't be removed from the cache easily. So as soon as the post becomes older, like and people stop requesting this, it keeps going to the back of the cache, and thus then it is removed completely from the cache. So let's say a post 1 comes, post 1 is requested by some user, then post 2 is requested by user, then post 3 is requested by user, then again let's say post 1 is requested by some user. So this way, post 1 will again be requested by user, something like that. So whatever would be the least recently used will get evicted. So in this case, like P2 would be the one which was least recently used, right? So like P2 will get evicted, something of that sort. So, and the other thing is least frequently used. So basically it is same as like it can okay. So if we want to implement our LRU, we generally use doubly linked list and a hash function containing the reference to the node in the list. So generally this we stored for LRU. This is implementing using a doubly linked list and a hash map. So hash map is basically used to keep the reference of the node in the doubly linked list so that we can directly reach and do some deletions operations easily. So DLL, because doubly linked list, because it provides deletion and insertion in order of one time, and hash map to know the exact location of the node. So yeah, there is a famous lead code question also. You can attempt that. It's called least recently used cache as well. So let us go to least frequently used. So in this, we basically count the frequency of each requested item, and we just discard or remove the item from the cache which is least frequently used. So let's say there are 4 entries in our cache, and A is accessed 5 times in a period of 1 hour, B is accessed 2 times in a period of 1 hour, C is accessed once, and D is accessed 10 times. So we will evict C and then insert new entry because C was the one which was least frequently used. So this is also one of the eviction policies, as like pretty simple, right? So the third one is most recently used. So in this way, it is like opposite to the least recently used. So similar to most recently used, we will remove anything which was used like most recently, whatever it was used. Let's say there is A, B, C, and again you have used A, then you will remove that from the cache. So you might think why, because if you have to evict at this point, and your cache A, B, C, and your cache size is only 4, and you have to insert something new, then you will have to evict A. Even in the case of P2, P3, P1, P2, P3, P4, only P2 will only be evicted if your cache size is limited to 4 and you are adding a new item, right? Unless otherwise you will keep adding to the cache. So here, right. So here the most recently used one would be removed. You might think, why would someone want to remove most recently used from the cache? Now think of example in case of a matchmaking website, right? Matrimonial websites. Someone might not want to see the profile of a person if they have already seen that, in the past, or the previous one that they have seen is of the same person, then they don't want to see that again, right? So in that case, the application might want to evict that from cache, right? So similar to case of matchmaking or Tinder, you can call it, right? That this might be very useful. Another thing is random replacement. What happens in random replacement, our fourth strategy, your application can just randomly select an item and discard it or remove it from the cache, and then we can make a space for new items. So let's say you have A, B, C, D, A, B, right? You randomly select one item from the cache, let's say C, and remove it. So it's like a random replacement. Don't put in much thought. Just make a space for the new one. So yes, sometimes random replacement can be a thing when you're not sure of whether LRU, LFU, or MRU will do any benefit to you, right? So this is pretty much about cache. We have covered everything that might be useful in a system design interview. Hope you enjoyed it. If you like my content, please subscribe and like, because it will motivate me to make more such videos. I'm going to cover lead code, system design, low level design, HLD, everything in the coming videos. So please hit the like button, comment if you have any doubts, share with your friends, and yeah, see you in the next video.